Hey folks, so I missed the class. I was supposed to substitute teach for Miss Williams. So instead, I'm going to give you a little video about angle of elevation and angle of depression. So the homework coming into this class, you learned about SOHCAHTOA, and I saw the work that you were supposed to have done. I hope you did it. If you understood that, this lesson shouldn't be hard to pick up from where you were before. So your SOHCAHTOA, very important that your 90-degree triangle, you know where the 90-degree part is, and you can figure out things about a triangle using SOHCAHTOA. So this lesson's about word problems and angle of elevation and angle of depression. So let's take a look at the next slide. Suppose a person in a sailboat sees another person at the top of a lighthouse at a 2-degree angle of elevation. If the top of the lighthouse is 25 meters above sea level, how far is the person in the sailboat from the person at the top of the lighthouse? So let's take a little drawing, and I think you'll see what's going on here. I'm not actually going to do the problem. I'm just going to do the drawing. So we have the water. Here's the water. And the water's level, right? The water, but like by nature, the water's level. That's what it does. And we're gonna have a lighthouse. I'll change color because the water came out such a nice blue. So we'll make a brown lighthouse over here. And the lighthouse has a beacon at the top, and it is 25 meters tall. And you're in some sailboat. We don't want a brown sailboat. We want an orange sailboat. So we have an orange sailboat over here. And you're in an orange sailboat, big sail. And here you are. Presumably your eye is basically at sea level. And you have a 2-degree elevation to the top of the lighthouse. So that means that this angle, think of this as a triangle, this angle is 2 degrees. This distance over here is 25 meters. And you're being asked to find how far the person in the sailboat is from the lighthouse. You're being asked to find this measurement, the measurement along the water. Now, the reason this is an angle of elevation is because you are looking up versus horizontal. So if you were to look at 0 degrees, you'd be looking right along the surface of the water, but you're looking up an elevation of 2 degrees. So basically your triangle has some shape like this with a 2-degree angle here and 25 here and X here. And therefore you're going to use TOA, T-O-A, because you have opposite and adjacent. So you have tangent of 2 degrees equals opposite over adjacent. So opposite is this 25, it's opposite the 2 degrees, 25, over adjacent, which is the X, and you have an equation to solve. All right, so it gets you back to homework like you did the night before, but it's angle of elevation. So let's talk about the word elevation versus depression, the angle of elevation versus depression. I'm going to clear my drawing and get out of this, and we'll go to the next slide. So here you go. In this last problem, we were the boat, and our boat was here, the observer, and we were looking up an angle of elevation of 2 degrees, and this was the lighthouse. But if we were in an airplane flying, we might be looking down at an airport from an altitude of 30,000 feet. And the angle of depression would be the angle between the horizon line looking straight ahead of the airplane and what angle you're looking down towards the airport of. So angle of depression is looking down, and angle of elevation is looking up. And that's really the difference between those two things. And I think with that, that'll give you enough to do the homework. So if you would try the homework, that would be great. Appreciate it. You'll be ready to go when Miss Williams is back for the next class. Sorry I missed class. I hope you had a great hour. I'm sure it'll be something to laugh about in the future.